everyone. This will be a session on the trade-offs and synergies between the short-term and long-term AI safety problems. So there's a lot of different ways to talk about the trade-offs and synergies between the long-term and short-term here. So before I define what we'll be discussing in this session, concretely, we'll have a short word about what we will not be discussing in this session, which is this very common framing of this problem being roughly of the form, well, X is just a distraction, the real problem is Y, and then X is going to be something like algorithmic fairness, and Y is going to be something like long-term AI alignment. And Catherine, I know you have a lot of thoughts on this.
Yeah, so we all sat down to have a quick preliminary chat yesterday about what we thought was interesting to debate in front of this group and sort of what we agree on and what we don't agree on. So we all agreed that we're not going to address the question of whether governance or policy solutions synergize or trade off, because we all broadly agree that if you're looking at governance or institutional decision making about what's good to deploy, in what order, that there are synergies there and there's going to be a continuous path. So we're going to focus on technical research. When we say short term, we're going to talk about systems that exist today. We're not going to try and debate what's going to happen in 5 or 20 years and which of those is short or long. And when we say systems that exist today, that could be reinforcement learning systems that are running in simulation, so not necessarily stuff that's deployed in a product. When we say problem, we identified sort of a bifurcation between a problem as something that's causing harm and a problem that's something that's not acting the way we expect or we're confused about in some sense. And we're going to focus on problems as stuff that's not going the way we expect or confusions rather than concrete harms to individual or group people right now. And we're also not going to tell anyone to stop researching anything. We think research happens best when you're really fascinated in the topic that you're working on and feel really engaged in it. And so we're not going to go around finger wagging at anyone for researching the wrong thing.
You're all doing great.
Yeah, and we also identified that there's a difference in framing between, well, there are problems now and those synergize with problems later. And we can implement these solutions now, and we could implement those same solutions later, and we think both are sort of in scope to discuss.
Okay, so I guess where we found the most disagreements, I guess, is to what extent is near-term AI safety research contributing to the solutions to the long-term AI safety problems? Would you agree there was, yeah, okay. And of course, there's a question, of course, what do we then here mean by short-term and long-term problems? And these concepts on themselves are pretty fuzzy. Roughly, they mean, people when they talk about them, they mean about 2 different clusters. First cluster being these, as Catherine has mentioned earlier, these technical problems with the current or near future AI systems involving narrow AIs, the systems that are harmful right now, and problems and solutions for this tend to be more model specific. Examples of these problems are, as I brought up earlier, algorithmic fairness, differential privacy, but also stuff like adversarial examples or robustness to distributional shift. On the other hand, we have safety problems with the far future, very powerful AI systems, maybe even AGIs. We expect them to be harmful in the future. And when we talk about solutions to these problems, they tend to be more model agnostic. These problems include value alignment, corrigibility, naturalized induction. A lot of these problems we had explained earlier really well by Rohan. Of course, there are problems across the scale, and maybe this is not the best way to split up the space of AI safety problems. And we are going to discuss this today as well. So I guess we're going to start with the opening statements. First from Neil.
Okay. One way that I'd like to try and put forward a way of thinking about this particular question, what it turns on, is when we talk about short-term stuff, we're typically concerned about technology which is available now. And the question that we find ourselves asking, the questions are kind of the form, are the problems that we're facing now idiosyncratic? Is there something about the way that we're currently pursuing AI technologies now that we're going to abandon these problems later when we have better technologies and we have different paradigms? Or are these things going to persist? So the answer to that question is going to be some determinant of what the relevance of the current safety questions that we are discussing ends up, what relevance it has for the longer term questions. So, in terms of the synergies side, I'd like to break down the answer to this question, the question of are current systems idiosyncratic and are the problems that they're facing idiosyncratic, by answering it hopefully every possible way. Because I have absolutely no idea about the answer to this question, and I think if any of us claim to have the answer to this question, we're probably deluding ourselves. And by current systems, I mean things like deep learning, for instance, or machine learning in general. So let's look at the possible answers to this. So one possible answer is yes, everything about our current systems is going to be thrown out, and we're going to have better paradigms later in 10 years or 20 years or 50 years. And the AGI, the long-term AGI systems that we're going to build eventually are going to have no relationship to our current technologies. So if this is the case, then the answer for synergies, then our position for this would be one of deconfusion. Is that, look, we don't have any other way of talking about these long-term abstract ideas unless we try and resolve them in terms of current models. And let's do that as an exercise to make sure we get our terms down, to make sure we know how to think about them, and to effectively practice for the case where we have to deal with these in another paradigm, in another realization, in which case we don't want that to have to be the first time we deal with it. On the other extreme side, there's the case of no, that basically everything about the current systems is going to be the basis for AGI. So this is kind of like the AGI is deep learning scenario. And in that case, then there is almost a direct link between the short-term problems that we face and the AGI level problems, in which case we better think about them now in terms of the current system. So then there's this point in the middle of maybe there's some overlap, but there's going to be some other paradigmatic shifts. And in which case, there is a lot of value in us trying to figure out what actually are those going to be those short-term problems which are going to transfer over, and to try and expend the time now to figure out what the nature of those problems are and what potential solutions to those may be. And finally, there's the kind of answer to this of, well, who cares about what the answer to that question is? But there's actually a whole lot of new problems which surface as we start developing the current AI technologies, new fundamental problems that are arising that we realize are going to hold even in the case of whatever future technology, whether it is not based on the same technology. And these are sets of fundamental challenges that arise that, I'll just say very shortly, are things like, and I'll unpack these, we can unpack these later, are things like the specification gap, that what we ask for is not necessarily what we get, and what we want is not necessarily what we ask for. Or it could be this problem of distributional shift, that we build a system for one, like aiming to resolve problems in one space, but then we have to apply it in a different space. Or another possibility is, another potential fundamental challenge is just having learning in the mix means that we understand one nature of one part of the problem, but we don't understand the rest of the problem, and we rely on learning to basically fill in the gaps of our specifications. And that means that there is some kind of epistemic gap between how we understand the problems we're trying to solve with our AI or AGI systems and what we end up building. And this leads to lack of transparency, and then also the problems about robustness, which may manifest at the moment in terms of adversarial examples, but could manifest in any possible way in the future. So basically, whether these systems are idiosyncratic or not, the current systems are idiosyncratic or not, then there are relationships between short-term problems and long-term problems.
All right, thank you. Nate, would you go next?
Yeah, I disagree with this frame. On my model, if even in the extreme you noted, where even if we imagine that the deep learning path leads fairly directly to general intelligence, my model says that the reasons why those systems might be dangerous is not so much that they may be susceptible to adversarial examples, but rather this core problem where what you select for may well not be what the system is internally targeting, in the same way that the human brain was selected very heavily by natural selection for its ability to promote genetic fitness, to get its genes into the next generation. And yet, humans, a general reasoner, do not, when we wake up in the morning, we're not like, gosh, how do I get my genes in the next generation today? Our thoughts tend to, I mean, some people might, I don't. Not every day. My thoughts are also based on all sorts of things like, how do I have fun? How do I learn things I want to learn? How do I, bring about fairness? How do I solve this one math problem that I have in my mind? This is a case where the brain was optimized heavily for one thing, and the internal targets of the resulting optimizer were quite different. So you can imagine an analogy in reinforcement learning where you train a policy by reinforcement learning for some target X, and then the resulting system, if it's powerful enough to be a general reasoner, may well not be optimizing for X. This seems to me to be the core challenge in alignment, and a challenge that I think is not very well expressed in short-term systems because they sort of aren't clever enough. They sort of aren't doing enough reasoning for those to sort of really have internal optimization targets and for those to come apart. But preventing those from coming apart and sort of understanding how to have the internal optimization targets match some target of our choosing, this seems to me to be the core problem. And it seems to me that trying to better understand adversarial examples or robustness distributional shift don't attack this core challenge. So I think they have some use. I don't see them as sort of striking the heart of the problem.
Okay, thanks. Catherine?
Yeah, so one thing I just want to caveat is that I personally work on adversarial examples, so my examples tend to draw from that, but I don't think that's all of what we're trying to talk about when we say like short-term problems where we mean stuff we're confused about in current systems. So like Neil, for example, works on interpretability. So with that caveat, Nate, one thing that I want to sort of highlight is that you're saying that future systems won't be dangerous because they're susceptible to adversarial examples. They'll be dangerous because there's this mismatch between what we've attempted to select for with our training process and what it's actually doing. And while I fundamentally agree that nothing we have today is doing enough reasoning to come up with these like complex long chain optimizers for other targets, I do think the reason the adversarial examples problem is interesting is because it has a much milder version of a problem of that same flavor, where we've attempted to get a thing that recognizes dogs versus cats, and the way we've done that is we've thrown dog and cat pictures at it, and we've gotten something that is just fundamentally not doing what we want. Like, it hasn't actually learned the problem. And in this case, I think like the strongest case I want to try and put forward is that these problems today can inform problems we'll have tomorrow. I'm not sure that any fixes to adversarial examples today will also be fixes to the sorts of long chain optimizers or inner optimizers you might be worried about. But I do want to highlight that, and for those of you who heard my lightning talk, I made this.
Sorry to interrupt. Maybe it would be good to define what we mean by inner optimizers. It was mentioned a couple of times, but I'm not sure if our audience knows.
Let's see. Either of you feel like you have a better, what's that?
I hate the term for the record.
We can forget I used it. I don't necessarily want to open that can of worms right now.
It's roughly the thing that Nate was describing.
Not according to me.
I think we're going to drop that for now.
Okay.
But I forgot what I was saying. Oh, that examples of problems now I think are useful to like inform what might be problems later. Maybe I'll just leave it there for now.
Yeah, and final one.
Okay, so we've got a couple of slides. Okay, so this is a slightly different issue than the relevance of, say, adversarial examples to long-term safety. But I just want to address some issues that have already come up in the conference, like in Tim Huang's lightning talk yesterday and other discussions I've had. So I want to say that in general, there are big differences between the narrow AI safety issues and the long-term issues, the AGI issues. I want to emphasize it doesn't mean the short-term issues are unimportant. And thinking about this debate, I really think that AI researchers have a crucial role in thinking about the short-term issues, and that they would really benefit from sustained technical work, like the short-term issues, and not just like policy issues or like issues for like activists or policy people to work on. I think there are like rich technical problems there. So I just want to sketch how like one of the big differences that I see between long-term issues and short-term issues. So in terms of AGI, that is going to be superhuman in performance, humans can't reliably evaluate its actions on a sort of action-by-action basis, so on a very near-term basis. And we can't just wait around for the results of the AGI's actions. So you can't just say, well, we'll let this agent try and work on cancer research and try a bunch of experiments on humans, and we'll just wait 5 years to see whether they have any long-term side effects. Because we know that the agent is smart enough that that kind of action could have very bad consequences. So I think this is a pretty fundamental difference when it comes to comparing like what we need for AGI research with the kind of paradigm for training algorithms that is really effective today. And so if we think of some of the short-term safety issues where like these are issues where maybe people are actually being harmed today by deployment of AI, or they will be in the next couple of years. So there might be like physical harms or injustices. So autonomous vehicles. So in terms of the safety issue of autonomous vehicles, like humans can recognize the errors that the cars are making for the most part. Like we don't need superhuman drivers from superhuman like autonomous vehicles. Like if they were just the level of a really good human, that would be amazing. But at the moment, like humans can recognize the errors. The issue is not like how do you train the system or what's the training data, but more that the systems have very weak models of the world, right? They don't understand human drivers and how human drivers have a theory of mind and do reasoning. They have don't have enough world knowledge to drive in a very wide range of conditions. But the training method there can be the standard method that we used to, like trying to imitate humans, try and get feedback from humans, have humans hand-tune reward functions, things that won't work fundamentally when we're dealing with AGI. And then if we look at fair algorithms that are making real-world decisions, so they're often, the errors these systems make are very easy for humans to recognize. And they come about, again, because of like weaknesses of the system. It doesn't understand law, it doesn't understand morality, it doesn't understand causality and which features might be gameable. So I think that this is a really important difference. And I think there are a lot of continuities. So on the adversarial examples front, like I think even though there are other issues that making deep learning systems into safe AGIs that we face, so I agree with Nate's characterization, there are other important issues there. It seems to me that ultimately we want AGI systems to be extremely robust. Like robustness becomes more important over time. And adversarial examples seem to me like a very good way of studying that, where we have the amazing advantage in that kind of research that we have actual empirical studies that we can do, and empirical studies have just historically been incredibly important in AI. I think if you ask people like 10 years ago, what would the adversarial example problem be for neural nets? I don't think they would be able to come up with all the things we've learned from doing empirical tests. Lots of people thought, oh, these problems will go away easily. It seems like that the actual picture has been very different. So I think if there are areas where empirical study can be done, I think that's pretty advantageous in terms of making research progress.
Yeah. There seems to be some disagreement with regards to how representative are the near-term problems of the long-term problems. So Catherine, you said you believe that, for example, adversarial examples are a milder version of the problems Nate was discussing. Can you maybe explain why you think that?
Well, yeah, so the specific thing that I was trying to point out is that if you zoom out and say, we had a training procedure which involved throwing examples at it, or saying words at it, or hand-waving at it, and that was our training procedure. Can we expect this to do exactly what we want? We already know that with current systems, the answer is no, because we get things that you can change a single pixel on an image of a cat, and it thinks it's a dog, like literally one pixel. It's like very obviously not doing what we want. And then Nate is looking at sort of a problems that would arrive with different systems, not necessarily just like an image classifier. Yeah. Like, gosh, what kinds of training processes or ways of giving an objective to the system would like cause it to then do what we want. And I think that like being aware that these problems already exist and that we don't have a good way of like taking them out right now is like is a helpful thing to notice, I guess. And I'm not necessarily trying to claim that like fixes to the change a pixel and the cat becomes a dog problem are also going to be fixes to the kind of stuff that Nate works on, if that makes some sense. And I also just want to say that for the context of this debate, I'm pretty convinced that trying to talk about stuff we're confused about rather than stuff that's causing harm today is going to help us narrow on stuff that's like more helpful to talk about right now, because if you're trying to like fix the fact that self-driving cars are crashing, there are probably policy solutions today that are much better suited to that, or you're trying to fix like unfair algorithmic bail decisions. I think those fixes are policy fixes right now.
We refer to it as like the confusion research.
Right.
Yeah. I would expect Nate to, disagree. I mean, do you think that there are any properties of near-term systems that would generalize to long-term systems?
Let me just respond sort of directly to your take. I think the analogy does not seem very direct to me. Like it seems like if we try to draw a line around the problem that I'm trying to point to, which I readily admit I probably have not successfully pointed to with my flailing words. But it seems to me that if we try to draw a line that includes both the problem that you're pointing to in the sense, or the problem that I was trying to point to, and the sense in which image classifiers are not doing what we wanted them to do when they are susceptible to adversarial examples, then that we're just no longer talking, like it's just, we sort of zoomed out to a level of generality where I no longer feel this captures sort of my confusion, if you will, about what seems to me to be the core problems. So, like for example, let me see if I can articulate it. This model I was saying earlier, where it seems to me like the key difficulty is causing some general reasoner to be optimizing more or less for an objective of your choosing. My model is that you sort of can't really start talking about this all that much until you can take what Ramana told me yesterday that Dennett would call the intentional stance, in the sense that we have a whole bunch of nice theorems which say that if you have some piece of matter that's more or less acting like it can predict the world and is more or less acting like it can allocate scarce resources successfully to solve a variety of problems, then regardless of what's going on in there, it's a good predictive mechanism to talk about it as if it has beliefs and has desires. This is making no claim about whether it has a beliefs.txt file or a like desires Python function or whatever. But we can sort of take this stance where we're like, it did that thing because it had deleted its previous relevant knowledge because it didn't think it was going to see this problem again. And making no claims about the internals, there are certain types of systems that will behave in such a way that this language is descriptive and predictive. And the sort of problems that I'm trying to point at of like, how do you get, like there's this way you could take the intentional view and say, we can ascribe goals, and these will be predictive. And the problem I'm trying to point at is the one of like, when you have a system that has this property where ascribing goals and beliefs is in fact predictive, how do you get it to be the case that the goals you would abstractly prescribe if you were trying to get the most predictive ascribed goals match the target against which you trained it, the target against which you selected it. And my basic model is that an image classifier is not close to being the sort of thing where this intentional stance applies. Like it doesn't seem to have enough of the machinery to me that it makes sense to talk about it as having beliefs and having goals. So I just don't see a way to draw that line.
So I would agree with that on the case of image classification systems, that it feels like from a human perspective that's a bit of a stretch. But I think you only need to go to the world of MDPs and POMDPs and reinforcement learning in order to make that kind of intentional stance very natural. So just routinely, when you see any RL researcher talk about their work, they immediately adopt the intentional stance. When they show their agent doing stuff, they talk about the kinds of goals that this agent has within this complex temporal decision-making context.
Okay, so maybe let's take some audience questions at this point. We're getting close to lunchtime.
So I wanted to throw something at, I guess, all of you, especially concerning the near-term safety issues with AI systems. I'm a little bit surprised, especially, I think, having an engineering background, when I hear about the short-term AI safety problems, and I mostly hear about, image misclassification. Right now, we have, I think, a lot of pretty complex automation systems operating in the real world that are, in fact, safety critical. They're in control of physical systems in the real world, where if the automation goes wrong, something really bad happens. They can have serious personal injuries or loss of life, or just big material damages. And it's often systems that have little to do with machine learning classification. They have a lot of different moving parts that are interacting with each other. Often it's distributed automation. You have anything from, I guess, the self-driving cars that we're trying to build, but also existing systems like the power grid or nuclear power plants that are heavily automated. And it seems that, and I'm a little bit worried that we might be getting a little bit of field myopia or tunnel vision, and we're looking at what we're doing right now in machine learning systems, but we're not looking at the much broader field of automation and what they are doing about safety with their currently existing and very real, very present safety problems. So I wanted to kind of throw it at you and see if you have any thoughts on how what they are doing about safety should inform how we think about the safety of our increasingly intelligent AI systems going forward.
Yeah, so I want to strongly agree with you that I think that in as much as there are problems with safety critical systems that are currently deployed that like an engineering, product, society integrated systems view is like entirely appropriate for. And that calling the stuff that we're trying to scope this debate to myopic from that stance is like a valid criticism in some sense. Like in our preliminary discussion, we deliberately decided to focus what we're talking about on like deconfusion, like what are we confused about today, and not what's causing harm today. And I think those are quite different problems which need quite different solutions. So like one thing I've been paying attention to, thanks to Peter Eckersley bringing this up, is that California recently passed a law that mandates the use of algorithmic systems in making bail decisions. So this is like some sort of linear regression making like life and liberty decisions for real people. I don't study that, but I think it's critical, and I think that like groups like the Partnership on AI have a role for like addressing this and coordinating responses to this, and that's very important. I think from a policy and governance standpoint, these sorts of decisions, how we make them as a society from a governance standpoint is like absolutely on the like set of steps that we're going to take to making similar, life and liberty decisions in the future, but that they are different from what a researcher who's trying to understand a problem is going to be looking at in their toy problems in the lab. And I think adversarial examples are a toy problem in the lab, and they have value in that sense. But if your claim is that studying adversarial examples is going to make self-driving cars any safer, I think that's a reasoning error.
Beth?
Hey, I kind of want Neil and
Nate?
yeah.
Or wine?
No, and
Catherine?
Me.
Jelena?
there.
Great.
Very person. Nate. Sorry, Neil was overriding Nate in my brain. Anyway, for you two to talk about like the closest examples in current RL systems that we might see to like what the long-term concerns are. So I think I remember in the Capture the Flag paper, you have like a separate reward predictor module. So you've got the like at the end of the game you win or lose, but that's not very helpful for like making decisions within the game. So you have some predictor that has things like who has the ball, is it my team, or who has the flag, is it my team or the enemy team, and like you might then get the RL agent like learns to do things that get you the flag, which isn't exactly the same as the end goal of winning the game. So whether that's like the same thing.
Yeah, okay, so I think this is a good point to go back to a point that Nate made, which I feel like is much of the crux of the disagreement here, which is about whether the particular challenges of alignment, or how I would describe it as also being specification, whether they're well expressed or not in the current deep learning and reinforcement learning paradigm. And whether, like, in some ways, is this a difference in quantity or a difference in kind? So what I mean by that is we're basically in the situation where we say, look, we want X. We don't really know how to say we want X. We kind of implicitly want X. We say we want Y. We write down that we want Z, and we end up with a system. What's after Z?
W.
W, okay. Then we end up with a system which, in order to get Z, ends up getting W, because our expectations of what Z actually means in mathematical language, we're still kind of fudging our way around this, and we don't know what the consequences of those particular specifications are. So whether that difference between W and what was the original thing, X, the difference between W and X, oh, I made the cycle, this is fantastic. Whether that's actually serious or not, and what the consequences of those that ultimate misspecification are, it's already present, and it's already deeply problematic in deep learning and reinforcement learning. Like the example, adversarial examples is one phenomenon of this case. Reward learning and inner loops of reward learning using algorithms that try to take very complex optimization algorithms, complex optimization problems that are like very sparse reward problems, and try and enrich them and create auxiliary targets, is one way that you end up with behaviors that you're not really expecting at the end of the day. How bad this problem ultimately is, whether it involves this, I know we didn't define it, but inner loops of optimization or instrumental goals or anything really potentially like runaway in the middle that might really not be what we want. I agree, we probably don't have systems that are that dramatically bad that we end up destroying ourselves when all we wanted was a coffee. That we're not in that situation yet, but we do have models of those. And I think that there is good work to be done to explore what the consequences are, what the signatures of these things are, and what potential mitigation strategies we might use.
Richard or David?
Yeah, two quick questions. So the first one is, for the people who think that working on short-term, like things we're confused about is important, how much better is it to have people working on that who are thinking about applying those deconfusions to long-term issues compared with people who are working on those problems just for the sake of those problems? And then secondly, when we talk about long-term issues being very important and also short-term issues being very, very important, right? I think like both of these things are true, right? We don't want to discard them, but at the same time, it's difficult to, how do we separate out, say, something that's like if you believe that something is orders of magnitude more important than another thing, but both of them are very important, how do you like convey that like prioritization in a way that doesn't sort of minimize, it doesn't sound like you're minimizing, say, short-term issues? Yeah.
Sorry, I didn't, so the first one was, is it better that folks doing short-term deconfusion are also thinking about long-term, and the second was how to talk about this to avoid minimizing concerns?
The second one is something like, if short-term issues are very important, how do you then make the claim that long-term issues are, like if you believe that they are several orders of magnitude more important, how do you make that claim in a like sensitive and reasonable way?
I can take the first one. I mean, I think it probably does make a difference for people to be concerned with long-term issues. So if we take adversarial examples, there's a huge number of papers on this topic, some of them aiming at fairly practical things, and there are practical problems with adversarial examples. Some of them aiming at like proving theorems, doing verification, thinking about this in a very abstract context. So like, what can you say about any classifier rather than just the particular neural nets we have today? So I think there will be advantages in people going at this with the mindset of, you know, how can we build robust machine learning systems where we don't know exactly what machine learning systems we need to make robust, and And so we want to always aim for a level of generality. So, but I think even people just focusing on the questions today without an interest in the long term may still do really valuable work.
Yeah, so I wanted to try and disentangle a couple of the claims and see what people thought. So I heard two core claims from Nate. One is that this problem, which I would like to call inner optimizers, is an essential problem that needs to be solved. And another one is that we are not in a position to study it today. So I'm curious if I've characterized that correctly, and then if other people disagree, which part of those two claims they disagree with. And then I guess I was also curious, although I don't know that we'll have time, to hear Nate justify the claim that we're not in a position to study this today.
This was the final question.
I think I'm not super interested in justifying the claim that we're not in position to study it today, because I consider myself to be studying it today. And what was the first part?
The first part was for everybody to see if you disagree with this claim that this is an essential problem that must be solved, and if you think that it's, I guess maybe I should rephrase it as nothing else is relevant to it other than like what Nate is doing or something like this.
Oh, I'm sure it could be studied ways other than what I do. Although I do agree it's essential and needs to be studied. That Nate guy, I think.
I kind of feel it's not clear that it's essential. I don't feel I have a great handle on it. Like, I think the evolutionary analogy is pretty misleading. Like, we're trying to build AI, we're intelligent. Evolution is this dumb process. So there's a lot that we can do that evolution was not able to do. So I think, like, you know, it's unclear exactly whether this will be a problem if you're working with deep learning type systems. So.
I would really love to hear from Neil and Catherine on that as well.
Ellen was going like this.
Sorry.
Unfortunately,
I think people are very eager to eat. So
we will need to bring the rest of the discussion to lunch. So I'd like to thank our debaters for a really interesting discussion.